The universe is gaslighting you. Welcome to Truth Duel Official. In this video, you'll learn how the vast and apathetic universe is always watching you. Yes, you. You'll want to stick around till the end of this video to learn how to avoid letting this video hurt your brain too much. But first, I am your host, Misinformation. If you like this channel, make sure to subscribe to receive more great quantum weirdness, misinformation analysis, and other sentiments and ramblings that please and amuse us. And become a truth dueler, because only you can slay misinformation at its source. Get our app on truthduel.com. This video exists purely to break your mind and everything you hold dear about your existence. Perhaps you spend every day believing that you can only directly affect the things you touch. Maybe you believe your environment is mindless, unaware of your presence. Most common of all is the belief that you actually exist in this world, that this world couldn't possibly be a figment of your imagination. Unless, of course, you're a physicist. Physicists don't believe any of these things are a given. Physicists want to dissect everything we know to be true so that they can find the real truth. And often that real truth is a lot stranger than we previously believed. So sit back, relax, and have an existential crisis as we take a look behind the veil of physics. Let's start small. That shouldn't be too weird, right? Wrong. Things get super strange on the small level. So weird that time may not even exist on the minuscule quantum level. But don't worry about that too much. First, we're going to break your brain by showing you how the simple act of observation changes how the universe behaves. The double-slit experiment was conducted by Thomas Young, and it showed the world how tiny particles, such as photons or electrons, behave both as individual particles and as waves. Young put two slits into a sheet of metal, and he shot electrons through the slits at a backboard. If electrons were individual particles, then they would hit the backboard and create two lines, just like if Young had shot paintballs through the slits. However, if they were waves, then they would create multiple lines because of ripples interfering with each other, just like if Young sent a wave of water through the slits. At first, the electrons acted like waves, creating multiple lines. However, things suddenly became very spooky when Young tried to measure these electrons. The moment he set up a device to measure them, they began behaving like particles, only creating two lines on the backboard.
If I sent a wave of water through the double slits, it would split in two, and then the two sets of waves would intersect. Their peaks and valleys would combine, getting bigger in some places, smaller in others, and sometimes they'd cancel each other out. With the height of the water corresponding to brightness on the screen, the peaks and valleys would create a series of stripes and what's known as an interference pattern. So, how could electrons, which are particles, form that pattern? How could a single electron end up in places a wave would go?
All right, so who was going to tell me that physics was just a code word for sorcery? What does this mean, and why do the electrons act differently? The prevailing theory surrounding this mind-bending phenomenon is called observer theory. Observer theory states that the very act of observation itself changes the way objects behave on a quantum level. If that didn't make any sense to you, let me explain it this way. The universe knows that you're watching it. When you try to measure the universe, it responds by changing its behavior.
Simply by not watching which slit the photons pass through. I know it sounds crazy, but in every trial ever conducted, the outcome depends on whether or not the experiment was observed.
This is because objects like electrons and photons exist in a weird quantum state, where they're not really one thing, but they're not really the other. This means that they can be in two places at the same time, and only when you measure them do they pick a place to be in. If you were an electron, then you would be both alive and dead at the same time. And only when someone looks at you do you randomly decide to be a corpse or not. Only that choice may not be so random.
What's in the box, Schrodinger?
A cat, some poison, and a cesium atom.
The cat, is it alive or dead? Alive or dead?
Answer him, fool.
It's a superposition of both states until you open it and collapse the wave function.
Says you.
There's also a lot of drugs in there.
Without getting too complicated, let's talk about spinning. Electrons love to spin, and they have a choice. They can spin up or down. Normally, they're spinning up and down at the same time, until you look at them. Then they choose a direction. However, this causes spooky quantum stuff to happen. If you measure an electron and it chooses up, then the next electron you measure will be down. Always. Any random electron anywhere in the entire universe will always be down. How is this possible? Well, our Truth Duel investigative reporters have been working around the clock to crack the case. And the answer they've discovered is, we don't know. We do not understand how electrons seem to be connected to each other across time and space. We do not understand why our observations influence the behaviors of seemingly random electrons. But we do understand that this experiment has produced a very strange implication. If electrons can communicate with each other instantaneously across the universe, then that means one thing. They're sending information to each other faster than the speed of light. This is called quantum entanglement, or more colloquially, spooky action at a distance. It's the perfect puzzle for when you'd like to stay up late thinking about your cosmic insignificance. This conundrum still baffles scientists to this day, especially 3 physicists that won the Nobel Prize in 2022 studying all this quantum confusion. John Clauser, Elaine Specht, and Anton Zeilinger all put their heads together and produced an idea that spooked physics to its core. The universe is real, but not local. What does this mean? The universe being real answers a long overdue question. If a tree falls in the forest, then it does make a sound. Being real means that an object exists even while someone is not observing it. However, it is that act of observation that has proven that the universe is not local. Being local means that the object can only interact with other objects in their immediate vicinity, and that information cannot travel faster than the speed of light. As we've learned earlier, it seems that objects can interact with objects far outside their immediate sphere of influence. 2 electrons can simultaneously communicate even if they are at opposite ends of the universe, a distance that would take longer to travel than the universe has ever existed for. Now it's time to really twist your mind. What if I told you that your brain imagined all of this physics on the spot? In fact, your brain has just imagined this video, the computer you're watching it on, the place you're watching it in, even the planet you exist on. Misinformation! You cry despairingly. Why would my brain do all that? The answer is simple, of course. It's less random for the universe to create a floating brain with memories than it is to create an entire world. Okay, let's pause and rewind to digest that fully. In the late 1800s, physicist Ludwig Boltzmann created a thought experiment about the randomness of thermodynamic equilibrium. Those are a lot of big words. So, to put it more simply, Boltzmann said that if the universe is infinitely expanding for an infinite amount of time, then there are an infinite combination of particles that can randomly combine. After doing an absurd amount of math that looks more like wizardry than science, Boltzmann concluded that it is more likely for a brain with false memories to randomly combine into existence than it is for the universe to actually exist in the way we know. That is, it is mathematically more likely that you are a Boltzmann brain floating in a space than you are actually a human being on planet Earth. Thankfully, we've reached the end of this video. No more spooky action, no more quantum weirdness, and no more floating space brains. Of course, now that you know this, it may be difficult to continue living your life in the same way. You will know hidden deep somewhere in the back of your Boltzmann brain that the universe is responding to every action you take. It is always watching you. Misinformation wishes you well and reminds you not to think too deeply about this, if you'd like to keep what little sanity you may have left. P.S. Could there be extraterrestrials that can harness quantum entanglement? Would they be able to influence things on Earth? And what does the government know about this that they're not telling us? Maybe you'll find the answers to these questions in Luis Elizondo, Counterintelligence and Intelligent Aliens. Until next time, make sure to like our video, subscribe to our channel, and become a truth dueler. Or else we'll keep making scary physics videos.